Good evening to everyone. Okay. So yesterday we have seen about example that is a single closed loop system. Now we will try to learn about the how we are going to do the calibration. Okay, so that is left anywhere. If we do the calibration, this is the same way how we are going to do it. Finally, wherever we see there is a transmitter, the transmitter which is going to give the output always 4 to 20 milliampere or 0 to 10 volt analog signal. 0 to 10 volt analog signal. Okay, so that is the standard format output it always gives. Now here we have written, you can see here, that is what we have seen yesterday. That is TT, temperature transmitter. Now temperature transmitter, that means if we say the temperature transmitter, means there is a temperature sensor and there is going to be the transmitter. Now this transmitter is nothing but this is a signal conditioner. Signal conditioner. Now this signal conditioner always gives the output 4 to 20 milliampere or 0 to 10 volt DC. So this is a standard format.
क्या दबाया कप तुम्हें दबाने का नहीं
Guys, mute yourself. Okay. So there is always a standard format output. Standard format output. In the marine field, we are going to use always this 4 to 20 milliampere. So marine field, that is guided by ETC, Electrotechnical Commission. Okay, and there is one more organization that is there, that is the IEEE. So these are the two organizations are there. It is always guided by this. As per that, all the equipment which are there, if they are going to use the transmitter, that has to be 4 to 20 milliampere and 0 to 10 volt DC. So whenever we talk about the temperature transmitter, there are two things. It may be housed in single also. In single module, it will be there. Okay, or there is going to be a separate module. It can be. Okay, it can be in that way. So now, if you see here, this is the 4 to 20 milliampere control loop. Now, yesterday I have told you something here. If you remember, that suppose if we are going to give off this span or band, if we are going to give band from here to here, so this is a 10 degree centigrade. This is the proportional band PB. So this PB, if we are going to keep, so how to adjust this one? Now, how we are going to adjust this is, sorry. So what happened? We are going to break anywhere. Anywhere you can break because this is a closed loop system. So just you can take out from here or anywhere, just break it like I am breaking here the circuit. Okay, this is the closed loop. And I am going to put a milliampere. Milliampere means this is a multimeter. So multimeter you need to put into the milliampere. Okay. So current, more milliampere you can put it. Remember multimeter, the lead what you are putting, this multimeter should be in series with the circuit. It should be in series. Then only you are going to check the current. Now what you are going to do is put the temperature transmitter sensor, okay, to the calibrator, to the temperature calibrator. Temperature calibrator. Set the temperature 40 degrees centigrade, and when it is going to reach to the 40 degrees centigrade, okay, and if it is reading 40 degrees centigrade, it's okay. If it is not reading 40 degrees centigrade, if it is 40 degrees centigrade, it will read 4 milliampere. It is going to, because 40 degrees centigrade, it's supposed to read here 4 milliampere. If it is not going to read 4 milliampere, you have to set by the zero potentiometer. Okay. So that is already I have told you yesterday also. So this is the 0 port we are going to adjust. Now set the temperature calibrator and go to the 50 degrees centigrade. It's supposed to read 20 milliampere. And if it is not reading, in that case, you need to set with this span. Once you have set with the 0, do not touch it. Okay, and thereafter you need to only adjust by the span. So the multimeter should read 20 milliampere. This is how we do the calibration. This calibration we have to do in the transmitter as well as we have to do in this also. This is a temperature controller. So in the controller also we need to do the same setting. That means when it is going to flow here in the circuit 4 milliampere, this controller will come to know it is a 40 degrees centigrade. And if it is going to read 20 milliampere, this controller will come to know 50 degrees centigrade. The mid of this one, whatever the current it is going to flow, it will be between the 40 degree to 50 degrees centigrade. Okay, it is going to be like this. Clear? So this is how we are going to do the setting. Okay. Now, there is a generally we have the temperature steam through that whatever the heating we are doing, we are going to have the temperature control, and we have like this in the steam. Anywhere if you see the temperature control, generally it is done in this way. There is a temperature control. Okay, like tank heating and all, this is done like this. So you can see here. Here we are heating the water. So we want a hot water in this case. Okay, this is the hot water that is here. So what we are going to do for anything, as I have told you in the closed loop control systems, first thing is the sense. So there is a temperature sensor that is put here. The signal is given to the controller. Okay, so from here the output sensor signal will come here. The controller that is having the comparator, it is going to compare with the state value. Whatever the state value is there, it is going to compare with that. Okay, so after the comparison, it is going to respond of deviation, because after comparison there has to be the deviation, and that deviation may be 0 or positive side or negative side. So as per that, it is going to respond, and it is going to give 4 to 20 milliampere. This particular part is generally used wherever we are going to use a pneumatic control valve. So this control valve is a pneumatic control valve. Okay, pneumatic control valve. Now, pneumatic control valve, generally on top we have the diaphragm, and we are going to give a pneumatic signal. So that will be proportional to the 4 to 20 milliampere. That means 4 milliampere is going to be 3 psi and 20 milliampere is going to be the 15 psi. So this is the PSI pneumatic signal we are going to do. We required a converter. So this IP converter is going to convert the current to pressure in proportion. In proportion. So it is going to convert, and that's why the name has come. Current means I, and pressure means P. So that is the name IP converter. IP converter. So that is how the name has come. So this valve diaphragm is going to move this stem, and this valve is going to open and close. Accordingly, it is going to control the flow of the steam. So it is going to control the flow of the steam. So that the temperature, that is required temperature, whatever it is set temperature, it is going to be same. Okay, so that temperature is always maintained. So this is how the closed loop control system works. Now electronic type, we have the PID controller. So PID controller circuit diagram, that is like this. This is the circuit diagram, and this is the PID controller. Okay. So this is with the operational amplifier. Try to remember this one. This question has been asked. And there is a summary of mode control and responses. Just now, this also question has been asked. Okay, this also has been asked. So this also try to remember this one. This question has come. In the oral, they are asking, make a graph of the on-off control, proportional control, P plus I control. This has come. And that is the this one, summary of mode control and responses. What is the response? This is the response. And there is the another one that is here. So this is the response of P and D. So this is the response of P and D. And similarly, there is a response of P plus I plus D. So this has been asked in your order. Now, let's see one more single closed loop control system. Single closed loop control system we'll see today. One more control system. So this is a single closed loop control system. And in this one, we are going to have a jacket cooling water single controller. It is a single controller. So if the single controller is being used, there may be the dual controller, there may be the single controller. Okay, this is the example of the single controller. Now, for any closed loop control system, as we have studied, there is going to be a sense. Sense means temperature, TT. So this is doing the work of sense. So this is the sense. Okay, so this is the A. Then it is going to be compared with the set temperature. So that is the B, that is the compare. So with a set temperature and the feedback, that is what the feedback it is getting, it is being compared with that one. And temperature controller is going to respond as per the deviation. So that is the response. When it is going to respond, it is going to give the control output and it is given to the temperature control valve. This temperature control valve which is going to move the three-way valve. This three-way valve is going to divert the water. Now the water flow, just you have to understand this one. Suppose the water flow is directly, it is going through this to this one. So this is a outlet here, this one, and this is going to be the inlet. And this is also the, here, this one is also the inlet. But this inlet is closed 100% and this one is open 100%. That means this water is being circulated here. Now, if this inlet, this one, if it is going to be open, suppose 75%, like we can see in this way, like 100% opening. Okay, then 75% opening, then 50% opening, 25% opening, and the 0% opening. Okay, so this inlet we will give the name here. This is the circulating water, so we will give the A port, and this is the cooling water. We are going to give the B port. Okay, so there is the A port. And there is going to be the B port. B port. Now what happens if the 100% A port is going to be open, B port is going to be open 0%. Just opposite. If it is going to open like this, so it is going to open 25%, then there is going to be 50%, then it is going to be 25%, and it is going to be 100%. So who is changing this position of the port A and B? How much the water is going to be allowed? Okay, if it is 100% water is going to be allowed from A port to C port. C port is the outlet port. So if it is allowed, in that case, 100% A port is open and B port is 0%. That means there is no diversion to the cooler. Now suppose if the temperature is rising, then slowly this temperature control valve is going to open and it will shut this A side port. So suppose it has open only 75%, that means 25% the water that is going to flow through this. It will come to the cooler, it will cool down and it will go through this. So this is the 25% water is diverted towards the cooler. Okay. Now suppose if the temperature is still is more, then in that case, this 50% will be going here and 50% is diverted. So 50% water is being cooled. Okay, so likewise, in proportion, you can see this is done by the control valve, temperature control valve, which is utilizing the three-way valve. So always the outlet is going to have the mix of water. Mix of water means there is a circulating water plus the cooled water. So it is always going to have the mix of water. And the set temperature generally we keep for jacket cooling water 70 degrees centigrade. So this is always at the outlet, it's supposed to maintain the 70 degrees centigrade. At the outlet of the main engine is supposed to maintain the 70 degree centigrade. Okay, hope you understood this. So this one, A, B, C, and the D is the response. So here, this is the response. Oh, sorry, effect. So this is the effect. So net effect that it will be temperature control valve. This is the final control element. As per the control output, it is going to open the three-way valve in such a way that always the temperature of the main engine outlet jacket cooling water supposed to maintain the 70 degrees centigrade. Okay, hope it is clear. Any doubt? Okay. Now, we are going to see a cascade level arrangement. Okay, cascade level arrangement. So cascade level we have not seen. So we should know the cascade arrangement. Let me add here. Cascade and feed forward control. Feed forward control. Cascade and feed forward control. Okay. Now cascade control, if you see the cascade control, generally wherever we have a slow process like temperature and level, we are going to have the arrangement, and this arrangement is going to be in this way. This is the arrangement we have. Okay, so this is the known as a cascade level control. Cascade level control, like here, I am going to maintain the level, and this is going to be a set level. So I want to maintain the level here. So this is known as a set level. Then I am going to do this master and slave control level. While we are doing for this one, there is a reason for doing this. First of all, when slow process is controlled by fast process, then cascade control is preferred. Okay, it is preferred. So it is going to be preferred. So slow process means like level control or temperature control. So this level or temperature control is always a slow process. And here if you see, it is being controlled by a fast process, and the fast process is by this flow of water. So flow control. So flow process or flow control we are doing. So flow control is a fast process. We are controlling the level by the flow control, and that's why this is a fast process. So wherever like this it is there, in that case, this cascade control is preferred. It is having the advantages. Okay, and second is that if any disturbances in this B or final where it is going to be in the level controller, that is the master level controller or primary. If any disturbances in primary, this is known as a primary control. Primary controller, then it can be eliminated. It can be eliminated. Okay, so we are going to eliminate the disturbances, that is the one. So that's why this is preferred. And second, it is being preferred if the slow process is being controlled by a fast process. Okay. So this cascade control. Now there is a certain thing that we should know in this cascade control. And here, if you see, it is given here that set point is going to be always in the primary control. Master control is also known as a primary control, and the slave is known as a secondary control. Okay, so there is a slave that is known as a secondary control, and this is known as a primary control. So there is a set point. We are going to have the set point always in the primary control. The output of this one is a variable because it is going to be the control output. Control output is always as per the comparison and as per the deviation, this output is there. So this output is always variable output. It is going to have its own feedback signal. Its feedback signal is whatever it is coming, it is going to have its own separate sensor, which is going to give the feedback signal. So now here the set point or set value is variable because this control output is variable. So this is also variable here. And it is going to have its own sensor, you can see, and from there it is going to have a feedback signal, and accordingly this is going to control the control valve. So the flow of the water is being controlled. Flow of water is being controlled. So we are going to control the flow of water. So the level of this one is being always controlled. So if any sudden change is going to come, the disturbances that can be also avoided. It can be avoided. Okay. So this type of arrangement, cascade level control, is used. The other name of this one is master and slave. This is also known as a master oblique slave, or this is also known as a dual control system. Dual closed loop control system. Because here we are going to use two controllers, you can see 1 and 2. So that's why the dual control closed loop control system, that is the name that is given to this. So either it is going to be the cascade level control, or we say master slave, or the dual, all are same. All are going to be same. Okay. Now this cascade control or dual control, the arrangement is going to be something like this. So this is a comparator. And here we are going to have the state value. This is the fixed state value. This is a comparator and it is given to the primary controller, or we say primary controller. Then the output of this one, that is given to the comparator, and the output of that one is given to the secondary controller, and this output that is given to the plant and process. Okay, so this is a control output that is given to the plant and process. Now here it is going to have its own feedback. So this is the feedback, individual feedback. individual feedback for master from separate point, not the same point. And here there is going to be the individual feedback for slave. Okay, we are written here secondary. You can write slave also. Primary, you can write master also. So this is a master controller, and this is going to be the slave controller. So like this arrangement are there, this is known as the cascade arrangement of the control system. Okay, this is known as a cascade arrangement of the control system. So in this, it is something like that. That should be noted. So note that master sets variable set value for slave controller separate individual feedback elements are used, and lastly slave controller controls the plant or process for desired output or desired output. Okay. So this is the slave control. Now there is something is known as a feed forward control. Okay, let's see about the feed forward control. Okay, we have one example for this also. Let's see that one, then we'll go finally for that. Okay, so there is a one example of this type. Okay. Now, so in this control, there is a tank where we are going to have the feed water. So this is the feed water. Feed water is feeding to this tank. Now there is a level control. So how much the level should be there to this one? This tank should maintain. So there is a level control. So this is the set point, that is set level. So we can say there is a set level to this one. So this one, this is the level controller. LC is a level controller. So this is master. So here the set level is going to be a fixed set level. Now this is the feedback, that is the level present value that is coming there. Level present value that is coming. So this is a feedback, a P that is coming to this one, that is the level. And this is the control output, CO, control output to FC. This FC is a flow control or flow controller. This flow controller is a slave and the output is given to this. So this input, that is the set value ASB. So this ASB is variable. Whereas here the set level is the fixed one. It is going to have its own feedback system. So there is a flow transmitter which is sensing the flow urgent value. So this is the feedback that is given to the slave controller. And finally, the control output of the flow controller that is given to the control valve. Okay, so this the control valve is known as a level control valve because the process it is doing to control the level of the tank. So level control valve. Now this level is being controlled by the flow only. Okay, by the flow. So as I have told you, the level is a slow process that is controlled by the flow. Okay, and that is the region here. We are going to have a cascade type. So this cascade control is preferred. So this is also known as a cascade control. Okay. Now feed forward. Now feed forward is generally it is used feed forward. Now these all are the feedback control, okay? But there is a one more control that is used along with the feedback control. There is a feed forward control is also there. Feed forward control. Feed forward control. Okay. Now feed forward control, wherever it is being used, feed forward control, wherever it is being used, it is used only for eliminating the disturbances. Now, how it can eliminate the disturbances? Okay. Now, feed forward and feed back. Feed forward and feedback control. This is the two entirely different concept. Okay, it is having a entirely different concept. What is the concept behind this one? This is going to work feedback control, controller or control. It works on giving feedback, of present value. So upon receiving the feedback, corrective action is taken. Corrective action is taken. That means if anything, if deviation is going to occur, and that feedback control system gets, then only thereafter it is going to give the corrective action. Okay, so that is the feedback. Now feed forward, just opposite of this one. Okay, if deviation is going to occur, here the deviation is already there, and thereafter the corrective action is taken. If deviation is going to occur, it starts taking the taking the corrective action. Okay, it starts taking the corrective action. Means before only it is going to take the corrective action. The deviation is going to occur before that. Now deviation, due to which it is going to occur? Deviation, it is going to occur due to the disturbances, because deviation means we are talking about a sudden deviation. Sudden deviation. Sudden deviation is there only due to this sudden deviation, whatever I have written here. This sudden deviation is there due to the disturbances. Okay. So here on giving the feedback of present value, this corrective action is taken. And here, if the deviation is going to take place, it will first monitor that one, and accordingly it is going to take the action before only. So there is no deviation. There will be finally the result is no deviation. No deviation. But how it is going to do? So this feed forward control, this is going to monitor. So we are going to have a monitor which is always going to monitor the deviations, sudden deviation or disturbances, and accordingly it is going to give the output. It is going to give the output. We'll see with the example of this one. So this is how it takes place. But here the complex mathematics that is used. In the feed forward, a complex mathematics that is used always. So this is going to be used, and that's why this is not a cost effective. But wherever we require a precise control and no deviation, then generally this is being chosen. Okay, so feed forward is being chosen. Whereas feedback control and feed forward both are used together. So if there is a no disturbances, system will work on the feedback control. And when the disturbance is going to occur, this will take over. Feed forward control will take over. It is like that. So in the normal condition, normal control, it will be done by the feedback control. And thereafter, if any disturbances, it is going to work on this feed forward control will take over. Now, here what we have learned, it is going to be something like this. Okay. So in the boiler, there is a one diagram that is very famous, but I hope, or I can say this one, that hardly people are understanding this diagram. Okay. And this diagram is the finest example of the cascade and the feed forward control. Right. No, I can say this one, that hardly people are understanding this diagram. Now, how it is going to be the cascade? So if you see here, it is going to have the, here, there is a dual or two control system or dual control systems. Okay, it is going to use the dual control systems. How it is going to use these dual control systems? So one input that is coming from the feedback system. So this is a feedback systems. This is the feedback. And one that is going to come from here. This is a feed forward system. Feed forward. So feedback and feed forward, this is a dual control systems. So both are being used here. So that's why this is also known as a cascade control system. Cascade control system. How it is a cascade control system? Let's see here. Yeah. So we are going to have the state label. So this is the state label. And we are going to give to the primary control. And our primary control, this is the comparator, and there is a primary control. And this primary control is P plus I control. So this is the primary control. This is going to give the output. Here the control output. And it is going to give to the summing network, and from here it is going to give the output. So this is the control output after this summer. So but this summer what it is doing, it is going to give the here one input, it is coming from here, and other input that is going to come here, and this is coming from the feed forward controller. Feed forward controller. So this is coming from the feed forward controller. So this is the control output of the feed forward controller. This is the control output of the feedback controller. And it is going to have the feedback, and that feedback is going to be from boiler water level transmitter. So it is coming from the level transmitter. Okay, and here there is a feed forward control. Now what this feed forward control is doing, it is going to find out the difference of flow. Difference of flow. And difference of flow it is going to get, that means there is going to be the two input of the flow, and that is going to come from the flow transmitter. And the flow transmitter, that is the steam flow transmitter. And there is going to be the water feed water or water feed water flow transmitter. Now, whenever the flow of this, we will say Fs steam, and here we are going to say Fw, that is the water. So if there is going to be the Fs supposed to be equal to the Fw always. If it is going to be equal to this, that means Fs minus Fw, it is going to be 0. Okay. Here we are assuming that Fs is equal to F0. So Fs minus Fw is always going to be 0. It's supposed to be 0. If there is a 0, there is not going to be any output from here. So there will be no output. So only the system is going to work on the feedback controller. Only the feedback controller is going to be active. Now, whenever there is going to be a difference, now suppose the steam demand has risen suddenly. Okay, that means now it is going to give a difference because the Fs reading is different. And that's why it is going to have the difference in the flow. If the difference in the flow is there, it is going to give the output. So now the output is there to this one. So it is going to superimpose on this whatever the output is there, and finally this output is going to go to the flow control valve. So control valve is going to open or close as per this. Now when this phenomena is going to happen, when this happens, that when the suddenly demand is going to rise. Okay, so this demand, if you see here, this is the same arrangement, whatever I have made down below, same arrangement is here. This is the stream flow transmitter and this is the feed flow transmitter. It is going to come to the differential relay, that is the differential F. If it is going to be zero, no output is coming here. And if there is a output, whatever, positive or negative, okay, then only that output is given here. And directly it is going to control the control block. Directly it is going to control the control block. That means there has to be a difference between the stream flow and feed flow. When this difference happens and how it is going to happen, okay, we need to understand. I hope if you understand about the swell effect. Do you know anyone what is the swell and shrinkage effect in boiler? Anyone know about this? Swell and shrinkage effect in the boiler? Okay. If you do not know, this is also known as a disturbances. Swell and shrinkage effect, it always happen in the boiler and this is known as a disturbances. This is known as a disturbances. Why it happening? It is going to happen because whenever there is a sudden increase in the steam demand. This should not happen, but if it is going to happen, then only this swell and shrinkage effect happens. Now let's see. When the boiler is operating, okay, then the water level means when the boiler is firing, the water level is always going to read higher, okay, when the boiler is shut down. So during the operation, in operation, water level always read higher than during shutdown. So if it is shut down, same water level is going to be less. It is going to read normal level. Okay, so it is going to read normal. But if we in operation, when the boiler is firing, always the water level is going to be higher. Why it is reading higher? There is a reason to read the higher because there is going to be a presence of steam bubble. Presence of steam bubble. Okay, so when the steam is produced and there is a steam bubble, that is the reason why the water level little it is going to be always higher. It is going to read higher. Now, let's see the one phenomena. Okay, and that phenomena that our there is a steam demand. So the flow of steam is increased. That means the demand has increased. Of course, the demand is increased. So the flow of the steam is going to increase. And if it is going to increase, that means next the pressure of drum is going to decrease. If the flow of steam increases, the pressure of the drum is going to decrease. And if it is going to decrease, okay, in that case, as the pressure is going to decrease, the steam bubbles, these bubbles which are there in that one, okay, it is going to flash off and become steam, and it is going to become steam. This we are talking about the bubbles, okay, steam bubbles. We are going to talk about the steam bubbles. Because if these bubbles were suppressed due to the pressure, but now it is going to flash off and become the steam. And due to this, what will happen? The level, water level will rise. Water level rises. It is going to rise. So steam bubble that is going to flash off and become steam, and that's why the water level is going to rise. Okay. So basically, the mass of the water is decreased. Basically, if you see here, the mass of the water is decreasing. Mass of water is decreasing, is fall. It is going to fall, but water level is rising. And this is known as a swell effect. Because the water level is going to rise, but mass of the water is falling, and this phenomena is known as a swell effect. Now, due to this swell effect, what will happen? Actually, if the mass of the water falls, it should fill up the drum. But water level is going to rise, that's why opposite will happen. Okay, it will close the flow of water. It will close the means the control valve will close the flow of water. It would have been happened other way around. It's supposed to do okay that it's supposed to open or it's supposed to increase flow of water. But it is happening in the opposite way. Okay, it is going to happen in the opposite way. And that's why this control is there. Now at this point, if you see here, now suppose this feed forward, this is not there, and only the feedback system is there. Now this level is going to rise here. If this level is going to rise, what it will do? Here, this flow of the water that is going to decrease. It is going to decrease. Whereas it's supposed to happen opposite. Because the mass is decreasing and only the level is increasing. So here the role of this one is coming, and that the time, because the difference of the flow will be there, because suddenly the steam flow is more. So if the steam flow is more, Fs, if it is going to be more than the Fw, it's supposed to be equal. Fs supposed to be equal to Fw. Now Fs has become more than the Fw, then there is going to be the difference of the flow. And if it is the difference of the flow is there, then it is going to give the output in such a way that it will open further. Okay, it is going to open more. More it is going to open, so it is going to fill up this water level. It is going to fill up the drum. Okay, further. So this is known as a swell effect. Every after swell effect, there has to be a shrinkage effect. Always remember, if the swell effect is there in the boiler, it has happened. Thereafter, always it will a shrinkage effect will happen. How it is going to happen? So when the demand was more, that time it has happened. Now the demand has come to the normal. It has come to the normal. When the demand has come to the normal, the flow of steam is also going to be normal. Okay, normal. It is going to be normal. If it is going to be normal, then the pressure of drum will increase. Okay, it will now rise. It is going to rise. Now, when it is going to rise, So steam bubble which were flashing off, now they will stop. Okay, so steam bubbles flashing will stop. Okay, and basically, if the steam bubble formation will reduce, we can say steam bubble, which were flashing off and becoming steam. So this steam bubble formation reduces. The another reason of this one is that because the cold water has come, because the cold water has come, and due to the cold water, bubble formation is also going to reduce. Why the cold water is coming? We have seen in the swell effect, we have opened the flow of the water. Flow of the water has increased. Can you see here? There the flow of water we have increased. And due to that, steam bubble formation, that is also going to reduce, or because the pressure is increasing, now steam bubble formation will reduce. This is going to reduce. And there will be the fall in the water level. So this is going to cause a fall in water level. Fall in water level. Now, if there is a fall in water level and incoming cold water, further it is going to reduce this. So water level is going to further fall down. Okay. So if the water level is going to fall down, in that case, the flow of the water will increase. Flow of water increases. Flow of water is increases. And this is known as a shrinkage effect. Shrinkage effect. Now in this case, what is supposed to happen? Now, if the fall in the water level, that's what it is showing here. Basically, there is no fall of the water. Mass of the water level is already increased because we are feeding the water. But level transmitter will sense that the level of the water is decreasing. It is going down. Whereas mass of the water is increasing because we have given already in the swell effect more water. Okay. And steam demand is also reduced. So it is going to sense in the other way. So if the fall of the water is there, it is going to open more water to flow. This will happen. But it would happen in this way, that it's supposed to decrease the flow of water. Decrease the flow of water. Now, who is going to step in here now? Again, same thing, because here again there will be a disturbances. Disturbances means there is going to be now the steam. Flow of steam is now less than the flow of water because it is getting a feedback. PI controller is trying to open more water level. Whereas steam flow is reduced. Already it has come to normal. Sorry, I have made wrong way. It's supposed to be this way. So flow of steam is less than this one. Again, there is going to be a difference in the flow. Again, this will step in and it will say stop. Okay, do not feed the water more. Okay, do not feed the water more. Water is sufficient. Okay, so this is how the feed forward controller, this is going to control the disturbances that is going to happen in the boiler water level control, and that is known as a swell and shrinkage effect. This is a disturbances. Swell and shrinkage effect. So hope now you have understood this circuit. Yes, any doubt in this, let me know. This water level control, whatever I am saying, it is there in the many books you will find, and this is used only in the main boiler. Remember, it is not used in the auxiliary boiler. Auxiliary boiler, I will give you the separate water level control system. Okay, I will give you. Don't worry about it. This diagram, most of the time people ask and uh, they try to, they think that you are going to make this diagram. Okay, they expect you are going to make this and you are going to tell them how it is going to work. So hope you have understood. This is a cascade or dual control system. Plus it is a feedback plus feed forward. Feedback means that's why it is known as a dual control, because it is going to have the feedback plus feed forward control system. Feed forward control. Both controls are there, and that's why it is known as a cascade or dual control. Okay. Any doubt to anyone up to here? Okay. Then we will go for one more, this master and slave. And that is also has come in your exam. So we'll try to complete this also. Now, this one is here, that is the master and slave, or we can say primary and secondary, or again we can say dual control, or we can say cascade control. But master and slave control is generally we say this. Okay, master and slave. Now, this diagram again, this is for the jacket cooling water temperature control. And here we are going to have the two control valve, and two control valve is being controlled here in such a way that the water which is going to be coming here out here, it's supposed to have the 70 degrees centigrade. That means the desired value, what we are going to set, this is the desired value, that is going to be 70 degree. So always, as I have told you, we are going to set in the master controller. Both are going to have a feedback, and that will be coming separately, individual feedback. So it is having the TT. So this TT, that is the temperature transmitter, that is at the outlet. That is at the outlet of jacket cooling water. And one more TT is there, you can see here. And this TT is there for the slave controller, and it is at the inlet. So here it is at the inlet, and this TT where it is at the outlet. So two different places and two separate sensors that is fitted, and it is going to give the feedback. So this is going to give the feedback here, and this is going to give the feedback here. This is a slave controller, this is a master controller. We'll say primary control. This is the first. Okay, first controller, primary controller. This is the second controller, slave controller. Primary controller, it is going to have the set value. So here we are going to have the set value. The output of this one, that is the control output. So this is the CO, control output. And this becomes a set value for the second controller. Now it is also going to have the feedback from the TT, temperature transmitter. Okay. And this is going to give the output. Now it is going to give the output to this control valve. So this is the control output, and it is also going to give the output to the seawater control valve here. So there are the two control valves. So two control valves are given. Now this type of cascade arrangement, this is a cascade control or dual control. So this type of dual control systems is also known as split range control system. Now where we are going to use this? Now remember the main engine, when it is going to stop condition, when it is going to be in the stop condition. Okay, it is going to be in the stop condition. Now, suppose if it is going to be in the stop condition, this one. So main engine is stopped. That time the jacket cooling water is required to be heat up. In that case, here this control valve. So we will say here the control will give the number like A and B control valve. So we will write here A control valve and B control valve. So now the main engine is stopped. So when the main engine is stopped, we are going to heat up only, and we do not require the cooling. In that case, B is going to be closed 100%. Okay, it is going to close, means open 0%. And here this valve is going to be suppose open 100%, like this. That means whatever the set temperature 70 degrees centigrade, this is being maintained by this one, steam control. Okay. Now if the temperature is going to rise from here, when it is going to rise, when the main engine starts, when the main engine is going to start, or when the main engine is full away. So when the main engine starts, that time the temperature of the jacket cooling is going to increase. We do not require just we have started the main engine. That means now the temperature is here, A valve is going to be open 75%, whereas this is going to open 25%. Now next what will happen? Now suppose the main engine is maneuvering is completed and it is going towards the full away. Again, this valve will be 50% and this is going to be 50%. When the temperature is much higher, it will go 25%. It is going to open 75. And when is main engine is full away, that time this is going to be totally closed. Okay, it is going to be totally closed and this is going to be open fully because we need to cool down now. Okay, cool down because the temperature of the jacket is going to increase and we require a cooling. So there will be no heating, only the cooling will be there. And this is how the main engine jacket cooling water system works on a varied load of wide range of main engine. So this is the question. This was the question that was asked. So if it is a varied load and in the wide range, how the main engine jacket cooling water temperature is going to work? So basically you need to make this diagram and you need to explain. So the question was only for master and slave closed loop control system we have to use for this type of split range control system. For the split range control system, so we are going to use this. Any doubt in this? Now, because it is a temperature controller, remember one thing, this first controller is also going to have the P plus I control, and this slave control is also will be having the P plus I control. As here you have seen, because these all are the slow control. Here it is written P plus I control. So slow control, like level control is a slow control. Always it is going to be P plus I control. Similarly, here also this is a temperature control. Temperature control is also always the P plus I control. But we are going to use a split range control system or very wide range. And that's why we need to control the two control valve. One is the steam heating and second is the seawater cooling. And that's why we are going for a cascade arrangement. This cascade arrangement is also going to eliminate the disturbances. It is going to eliminate the disturbances. And this is the what benefit we are going to have with this. Okay. So any doubt to anyone till here? If you are not having any doubt, then
Sir, can you please tell the calibration of controller once again?
calibration.
So you started with calibration.
This calibration you need to do, you put the multimeter in the series. Okay, then suppose if you are going to give the range here, I have kept the PV to the 10 degrees centigrade. That is the proportional band. So set value, that is the set temperature, I am keeping a 45 degrees. Okay, degree centigrade, and PV is 10 degrees centigrade. 5 degree each side. 5 degree each side. In that case, 40 degrees centigrade is going to be my lower value, whereas the higher value is going to be 50 degrees centigrade. Now we need to set in the temperature transmitter as well as the temperature controller, both the places. Okay, so here what I am going to do is I will put the temperature sensor because I am using here the temperature. So temperature sensor in the temperature calibrator. So we have the temperature calibrator set to 40 degrees centigrade. Okay, put here the multimeter in series. And when it is going to reach 14 degrees centigrade, it's supposed to read 4 milliampere. If it is not reading, then you set it by the 0. If it is a new transmitter, then you need to 100% you need to set it to the from the 0 port. You should make it 4 milliampere. Now increase the temperature to this one to 50 degrees centigrade. Okay, and adjust it by the span and bring it to the 20 milliampere. So now you have set the set value 45 degree and proportional band to the 10 degree. How the set value has been set? Because if you are going to set the proportional band, the mid portion means 45 degree will always read the 12 milliampere. You can check it also. If you check, and here just make it 45 degree, it's supposed to always read 12 milliampere. Here the mid value, okay, of this one. That means your set value is 45 degree and range has become 40 to 50. Got it? Now here in the temperature controller also there is a soft key here, you can see. Use this soft key, go to the manual, auto and manual, go to the manual here. Okay, it will be given in the data sets of the temperature controller. Go for the proportional band and gain. Do not set gain, just set the band, proportional band. Gain will be set automatically. You can set the set value and the difference. So in this one, it will be given set value. So you need to set 45 degree. Then there will be a difference. You can set plus minus 5 degree. So that becomes 10 degree. So this is a difference. Okay, plus minus, if it is given plus minus, then you need to set only 5 degree centigrade. If plus and minus is not given, just given a difference, that means 10 degree difference. Okay, so now it is going to be, you need to see the manual. Manual will tell you clearly. So you are setting here the 40 degree centigrade to 50 degree centigrade. So this becomes your band. Your gain is set automatically. As already I have told you that proportional gain is inversely proportional to the band. Okay, so if you set the band, your gain will be set automatically. Okay, clear?
Yes, sir. Thank you.
There is a question in the chat. Disturbance means which is going to affect the process output. This is the okay. I will tell you what is the disturbances. Disturbances. Kindly put your name, please. Like you have put Redmi. Do not put such name. You can put your name there. Instead of the Redmi, you can put your name. Okay. Disturbances. Now, disturbances means the external factors which influences the process output, which influence the process output. Okay, is known as disturbance. For example, suppose this is a ship. Okay? This is a ship here. And we are going to have the direction here. And suppose the ship is going to sail and it is sailing, this ship is sailing in this direction. This is the direction, or this is known as a course it's supposed to maintain. Okay, it's supposed to maintain this course. Okay, now if there is a wind that is going to flow from this side, so there is a wind. Okay, and this is the direction of the wind. Then suppose there is a swell. So there is a swell also in the water. So I have just made the straight here. So there is a swell. So in the water we have the swell. So there is a swell. And there is a underwater current. Okay, so if suppose the underwater current is this direction, This is the underwater current. That means the ship cannot maintain the desired course, correct? It is not going to maintain this desired course due to the disturbances. So this is the wind, swell, underwater current. Okay. These all are known as a disturbances. These all are the external factors which is going to influence the process also. Is known as a disturbance. Okay? Any doubt? Okay. Now let's go for the boiler. Okay, so we'll be seeing this boiler also. I am going to tell you two control. One is the water level control, and one more control I will tell you, and that is the steam dumping control. Okay, steam dumping control. So these are the two control I will be covering here. Let's cover today this one because this is a very big subject, boiler water level. So tomorrow I will pick up that one. Today I am going to tell you about this. Okay, and if time permits, then I will start with this also today. Steam dumping valve. So if you see the steam dumping valve, it is going to be generally when the boiler is going to work in the EGB, exhaust gas mode. So there is a two modes boiler works, and when it is going to be in the EGB mode, that time the steam is generally higher. That we keep higher that one because in the EGB it is going to work. So we are going to keep it little higher than required. So we should not waste our fuel. Okay, we should not waste our fuel. And that's the reason always it is going to work in the higher. And oil fire burner, that will be stop position. How it is being stop position? So let's understand that. Like if I am Kangrim or any other, if you have seen the manual, you might have seen there. Just I will take one example here. Like, sorry, we are going to have a auxiliary boiler. As you know, the auxiliary boiler that works on the pressure dependent. This is a pressure dependent. So suppose at the 5.5 bar, okay, these all are bar only, so I'll write here only bar. So 5.5 bar of the steam pressure, the auxiliary boiler, oil fire burner, it is going to start. So it will be on. The oil fire burner will start. It is a pressure dependent, so it is going to start. When the pressure is going to reach, suppose it is a 7 bar, okay, it is going to be off. Oil fire burner is going to be off. Now, if you see, next is your high steam pressure alarm, that generally it is going to come at the 8.7 bar. This is the high pressure. High pressure trip. This is the steam pressure and this is a trip. This is a trip. That is there. This is supposed to trip the boiler. But if it is not able to trip the boiler, at the 9 bar, you will find your safety relief valve. This will operate. This is the number 1. And if this is not able to operate, there is again one more valve is set at 9.1. Is the safety relief valve number 2 is supposed to operate. Okay. Now, this is the auxiliary boiler when the oil fire burner that is going to work between this and this. So generally at the anchor and when at the port, this oil fire burner that is going to work. When the ship is at sea, there is a EGB mode. So this is the oil fire burner. And thereafter, when the ship at sea, it is going to be the EGB, exhaust gas boiler. This is going to work. This is the mode, it will change over from here to here. Now, if the EGB is there, the main engine exhaust itself is the 250 degrees centigrade, 200 to 250 when it is reaching to the boiler drum. For the evaporator, if the evaporator separately is there, that is also same. Okay. Or it is the state tube or a smoke tube. The type of boiler is the drum, it will pass through that. Same 200 to 250 degrees centigrade, it is going to generate heat. So steam is going to be produced. Now, here we cannot control the main engine. Okay, main engine exhaust that is coming from the main engine. So speed we cannot decrease or increase of the main engine. Instead of that, what we can do, we can have a steam dumping control valve. But this is also a way, because we are going to generate from the exhaust, now steam is being there. So the dumping valve setting, the dumping valve, because it should not go to the 8.7 high pressure trip. Boiler should not trip on the high pressure, and our oil fire burner also should not start, because if it is dropping and coming to 5.5, it will start automatically. So we choose such a way that it's supposed to be between this and this, and that is what the dump pressure, that is known as a dump pressure, generally you will find at the 8 bar. So 8 bar we are having the dump pressure. Dump pressure that is being set. Okay. So oil fire burner that is also not going to start, and the pressure is always going to maintain in the service line, that is the 8 bar. So it will not go to the 8.7 bar. Also, it will not drop to the 5.5 bar. So our auxiliary boiler is going, means oil fire burner is going to start. Now, if you see here, the steam dump control valve, that is here, this one. So this is a steam dump control valve, and this valve is a control valve. So this is a control valve which is going to open and close, so that here in the steam line, the pressure is going to be maintained at the 8 bar. So this is the pressure it is going to maintain. Now for that, again, we required a pressure sensor. So here we are having a pressure transmitter. Pressure transmitter. So there is a pressure transmitter which is going to give the output to the, here it is written a control panel. Basically it is a dump controller. Dump controller. Here we are doing a steam dumping, and that's why it is known as a dump controller. Okay, so here we are going to have a set pressure. Set pressure, so that is known as a dump pressure. So we can write dump pressure here. So set pressure we are going to have. So we are going to set at the 8 bar. It is going to give the output to the IP converter. Again, the IP converter has come here. So this IP converter, and that is given the here inlet you can see here through the reducer. So at least here it's supposed to be 2 to 3 bar. It's supposed to be there to generally 3 bar, that pressure will be there after the reducer. Not required much than this because 3 to 15 psi, it will be hardly 1 bar, 1.5 bar, near about that. Okay, psi you can calculate. So 4 to 20 milliampere, that is going to convert into 3 to 15 psi. Okay, so at max here we required a 20 psi. Okay, this will be sufficient here. 20 psi, 20 to 25 psi, that is sufficient. 3 to 15 psi, that will be the that will be given, and this steam wall is going to operate on that. Whatever the current that is going to come, that is the 4 to 20 milliampere. So this current will come, it will be changed to 3 to 15 psi, and this valve is going to open and close. So the steam is down to this one. Okay, it is going to down. Through the atmospheric condenser, it will go to the hot well. It will go to the hot well. Okay, any doubt to anyone? Okay. Now, when we see about the boiler water level control system, so there is a level sensors we are going to use in this. That is the level sensors. Can you tell me which all types of level sensors you have seen on board ship? Boiler water.
DPT.
Okay. DPT. What is that?
Differential pressure transmitter.
Differential pressure transmitter. Okay.
And there was one with magnetic switches, sir.
Okay. Magnetic switch. So that is a float with magnetic switch. Okay. And no one has seen water level sensors?
Capacitive type.
Capacitive type. Yes, that's correct. Capacitive probe. Okay. And any other?
Radar type.
Sorry?
The radar type. I've not seen on board, but I have heard about this.
A radar type in boiler? No, we are talking about boiler, not the our this tank gauging system. Tank level gauging system is different. Okay, we are not talking about that. We are talking about the boiler drum water level. Okay, there is a conductive probe. Have you heard about this conductive probe? Now, float with a magnetic switch. So there is a variant in this one. There are two types. There is a float with magnetic switch and there is a float with variable resistor or rheostat, that is what we say resistor. So there are two types. Okay, DP transmitter, float with a magnetic switch, float with variable resistor, capacitive probe and conductive probe. Can anyone can tell me how the DP transmitter works? Anyone? Okay.
Sir, it measures the differential pressure in the boiler water tank level at different height and convert the signal into a level.
But how it is going to sense? How it is sensing the difference of pressure? Okay, we'll talk in length about this because there are the many traps in this one. Okay, traps. And generally people fail in the DP transmitter. As soon as you say DP transmitter, the surveyor is going to ask you too many cross questions and there is a many traps are there in this. We'll talk about this, okay, one by one. Let's see. So I will be starting not from here, but I will be starting from here. So I will go like this. Okay, first I will go to the conductive probe, capacitive probe, then float switches and float type, and there is a DP transmitter at last. Okay, let's see about the conductive probe. So conductive probe, if you see, there is a different type. This is a very simple and very robust. This is the boiler water level detector, or this is the control system. This is the robust one, and this is the fail safe. Remember this. This is the probe, which is a fail safe. It is not going to fail on. It is very fail safe. That is the advantage of the conductive probe. It is robust. And second, almost it is fail safe. Fail safe. Okay. This is how it is going to work. You can see here, this is the inlet valves. Here we are going to have the steam. And this side we are going to have the water level. So this is the steam valve and this is the water level valve. This is the chamber, this is the level probe chamber. And we are going to have the level gauge glass also. Now there is a porcelain holders because this is a conductive probe, that is generally the steel of different heights that is being put. Okay, different. Here you can see the top view. This is a side view, but this is wrong. Basically, this C is supposed to come at the center, but just for the purpose it has been made here. Okay, so C will be always at the center, and there is going to be the SP1, SP2, high water level, high water level, low water level, low water level. So this many probes will be there in the chamber. Okay. So now what happens from C, we are going to give the supply here. So if we are going to give the supply to the C, then the current is going to flow in this from here, control unit, it will come. And which all the electrodes that are in the water, the current is going to flow through that. So immersing this electrode which is immersed in the water, the current will flow back to that. Now suppose the level is going down here. If it is going down and suppose it is going to reach below this SP1. SP1 is a start. Okay. So this is going to give the signal. So it is going to start the pump. Start the pump. Already I have told you about this one when I was telling the water level control during the PID, if you have seen that one. So start pump signal that will come. So now the water is going to come up, and when it is going to touch this SP2 water level, now what will happen in this case? Again, the current is going to flow in this. Once the current start flowing in this, it is going to give the stop signal. So stop pump is going to be stopped. So like that, it is going to work between this. But if the water level is going beyond this, below of this one, LW or LLW, okay, LW, then in that case, LW alarm will come. That is the low water level. And if it is the LLW, this is going to be the trip. So boiler is going to trip on the low water level. Okay, because the current will not flow in this one and it is going to trip. Whereas HW and HHW, this is going to work in opposite way. So when the level is going to rise and it has raised up to here, the current will start flowing this. And if the level has raised up to this electrode, the current is again going to flow in this. When the current is going to flow in the HW and HHW, in this case, the alarm will come. And again, in this case, it is going to trip. Okay. So this is the very simplest one and very robust and very fail-safe. This conductive probe that is very widely this is being used. But remember, this is going to be used only for the on-off control system. On-off control system. It is used only for the on-off control system. Okay. Now next, we are going to have the capacitive probe. So capacitive probe, so this is going to work in the electrostatic charge. Okay, it is going to work on the electrostatic charge. The formula I have given already here, you can go through that. So capacitance that is going to depend, C is going to depend upon the electrostatic constant, the area of the plate. That means there is going to be two plates. Suppose this is a plate and this is a plate. And between that, we are going to have the dielectric constant. So this is the dielectric constant and this is the distance. This is going to be the distance between the plates. Then area of the plates, area means how much the area it is there in each plate, like this. Okay, so this is the area of the plates. Sorry. Then it is going to have the charge. Suppose this side it is going to be a positive charge, and this side it is going to develop a negative charge. So this charge is known as a electrostatic charge. Electrostatic charge. Now this electrostatic charge on the plates that is going to develop, that depends upon the dielectric constant, then area of the plates and the distance between these two plates. Distance between this. Now area of the plates and distance of the plates, if we are going to consider constant, okay, if we consider constant, then C is going to be K dot epsilon naught, that is the dielectric constant. Okay, so epsilon naught, and here where we can say K is equal to A upon D. Now, and thus we can say the C is directly proportional to the dielectric constant. Now what is this constant? This constant which is showing here, this is the here is having a different dielectric constant. Okay, here dielectric constant it is having, and there is a water, it is going to have its own dielectric constant. Now this both are going to vary. Here it is variable. This constant is variable here. Okay, can you see here? Because the water level when it is going to vary, these two is going to vary. Okay, it is going to vary. So if it is going to vary, then the charges across the capacitor, that is going to vary. And if it is going to vary, it is going to give the water level, that how much the water level is there, that we can find out. Okay, so this control signal, this level control output for transmitter, air control unit, that is going to give a analog signal, that is the 4 to 20 milliampere or 0 to 10 volt DC, a continuous signal or analog signal, continuous signal we are going to get. Continuous signal. Okay, it is going to give. So that means this sensor, this particular sensor is going to be used for the continuous water level control. So wherever we have the continuous water level control, generally we can use this one. Now, if we are going to have the float type, so float type is again, okay, I think time is already 10 o'clock and my throat is not okay today. So just I will conclude. Tomorrow I will tell you about this one. Okay, level float. And next again I will tell you remaining parts of this one. Okay. So any doubt up to here to anyone? So thank you very much and good night to everyone.
Thank you, sir.
Thank you, sir.